And welcome to this curriculum called Intro to Variables and Algebraic Equations. So first, here is a course summary. In this course, we'll be diving into what a variable is, what a term is, and more narrowly, what like terms are, and how to solve simple algebraic equations. And we're going to be diving into the property of equality and how to isolate variables. So first off, what is a variable? So first and foremost, a variable represents a number. So, in other words, it holds some numerical value. So, for example, it could be 2, 3, 10, 200, etc. They can appear in equations and expressions, and they are used as letters. So, some common ones are X, Y, and Z. They can technically be um, symbols, but they're not really used as symbols when using math. So here's an example of a variable equaling a number. So here x, which is a letter, is the variable, and it's equal to 2. And as I said here, it says 2 is what x is equal to. So that's just like the gist of what a variable is and how it's equal to a number. So now, what is a term? A term is separated by addition and subtraction. So if you have a whole sequence of terms, which we're going to get into later, um, the way to differentiate one term from another is by looking for addition and subtraction symbols separating each one, or addition and subtraction symbols in the middle of each other. They can consist of numbers and or variables, so they can be a single number. Um, they can have numbers and variables, or they could just be a variable. And there's different names depending on the amount of terms. So um, a monomial is one term, a binomial is when you have two terms, and a polynomial is when you have three or more terms. This won't really help you with any math, but it's just good to know the names of different amounts of terms in the future when referencing them. So here's just a little example of some terms. So here you have the terms 3x, 7y, and -4. Um, so you could see that they're separated by addition and subtraction. So you know that 3x is different from 7y, and that's different than -4. So I've been saying -4, and you might be wondering why. So the operation sign before a term is part of that term. So it's associated by that term. For lack of a better term, it's consumed by that term. Um, so here, since the plus sign is before the 7y, the 7y is positive. But since the negative sign or the minus sign is before the 4, this is now -4. And if you want to move these terms around, um, this -4 will always be -4. So the subtraction sign doesn't just stay there and the 4 moves around. This whole thing moves around. That's why I've color coded it like this. So you can see all the different terms. And when you don't have a sign in front of a term, like if it's beginning an expression, then you just assume that it's positive. And if you want it to be negative, then you always need to put a subtraction sign in front of it, even if it's beginning the sequence. But when it's positive, you don't need to put anything in front. So now, what are like terms? Like terms are terms that have the same variables in degree. So a degree we're not going into in this course, but just so you know, a degree is powers and exponents. So to be a like term, they have to have the same variable and they also need to be raised to the same power, but none of these examples will have degrees associated with them. So here are some examples of like terms. X and 2x are like terms because they have the same variable, x. 5d and 42d are like terms because of the same variable, d. 3y and 10y are like terms, and 6xy and 11xy are terms. Um, and you know that because these have the same variables, but they also have another variable, not just one variable, but two variables, and those can still be like terms. And the only way you can be a like term is if you have more than one variable, you have to have the exact same variables. So 6x and 11xy wouldn't be variables because the 6x doesn't have a y. So here are some unlike terms. X and 2y are unlike terms because they don't have the same variable. 5c and 42n are not like terms. 3y and 10xy are not like terms. And from the example I gave before, the 3y does not have x in it, so these are not like terms, regardless of if both of them have y. And 6cy and 11cn are like terms because one has n, another has y, and they don't share any variables except for c. So now let's combine some like terms. So here is an expression, 3x plus 2y minus 5x plus 2y minus 3xy minus 7 plus n plus 5 minus xy. So at first, this may look intimidating, but once you look at it conceptually and simplistically, it's actually not that bad when you know how to combine terms, or like terms for that matter. So when you combine like terms, you always combine the coefficients first. So a coefficient is the number associated with the variable. So when you have a number right before a variable, that signifies or means that the number is being multiplied by that variable. So in this case, 3x is 3 times x. In this case, 2 times y, negative 5 times x. Yes, it's one term, but it is one term because they're being multiplied together, not added or subtracted together. Um, and here, when you combine like terms, so 3 here is a coefficient and negative 5 is a coefficient. When you combine like terms, you have to combine the 3 and negative 5. So here on the next line, you're going to see it's going to be 3 minus 5, because remember, this is not 5, this is negative 5x. So it's going to be 3 minus 5, and then you add the x at the end. For the 2y and the 2y, since those are like terms, it's going to be 2 plus 2y. Here it's going to be negative 3xy minus xy, so that's going to be negative 3 minus 1. And when you have some variables without a coefficient, there always is a coefficient, even if it seems that there isn't. And that coefficient is always 1, because multiplying anything by 1 is the same thing. So this could be the same thing as negative 1xy. So here you're going to have to do negative 3 minus 1. Don't think there's a 0 there. It's not just negative 3xy, it's negative 3 minus 1xy. And then since these don't have variables, you're just going to do that regularly, negative 7 plus 5. And then since n doesn't have like terms here, it's going to be plus n. So now once we simplify those, it's going to be negative 2x plus 4y, then plus minus 4xy. And I said plus minus because I added all of these together. But negative 3 minus 1 is negative 4, so it's plus minus 4xy. And whenever you have a negative and a positive, it's always negative. So it's minus 4xy plus n, then plus minus 2. And then that simplifies to negative 2x plus 4y minus 4xy plus n minus 2. So that's the most simplified you could get when simplifying this expression up top. So now that we know like terms and variables, what is an algebraic equation? So an algebraic equation has one or more variables. So you might have solved equations in the past, but to be an algebraic equation, you need to have a variable associated with it. Um, and the point of an algebraic equation is solving for an unknown. So, and that in this case is the variable. And then many algebraic equations use many properties, but in this course, we're only going through what the property of equality is. So this is an example of an algebraic equation. X plus 3 equals 7. So here we're trying to solve for x. X is unknown right now, and we know that x plus 3 is equal to 7. So what we want to do is we want to isolate the variable. And your teachers in the future or now may use different terminology, but what we're using here is isolating the variable. And that basically means that you want x, the term with x, to be on one side and only one side. So in this case, you're lucky because there is no coefficient with x. So all you need to do is um, isolate it on one side, and you don't need to do anything else. In the future, we're going to be talking about um, ter variable terms with coefficients, but here it's only x. Um, and what we want to do now is we want to isolate x, as I just said. So we want to get rid of this plus 3 so we could have only x on the left side of the equation. So how do we get rid of this plus 3? So the only way to get rid of this plus 3 is by canceling the plus 3 out, or the positive 3 out. And that means that you want it to be equal to 0. So when you have 3, how do you get 0? Well, you subtract 3. 3 minus 3 is 0. So another word for that is the inverse of positive 3. And also, it's called the opposite of positive 3. So the opposite, or the inverse of positive 3, is negative 3. So what you want to do is you want to subtract 3 from this side so you get 0, because 0 is a neutral value, so it won't add anything to x. So once you get 0 here, then x is going to be by itself technically. So you need to do x plus 3, but to get rid of the 3, you need to subtract 3. And here, when you use the inverse of any subtraction is addition. So if this was negative 3, you'd have to add 3 to get 0. And then in this case, we're using addition, so the inverse of addition is subtraction. So here you can see x plus 3, and then you subtract 3 to get rid of the 3. But now, if you subtract 3 on this side, the equation won't be balanced or equal anymore, because you already established that x plus 3 is equal to 7, and now that you're subtracting 3 from one side, it's not going to be equal anymore. So what you need to do is you need to use the property of equality. And the property of equality basically states that whatever you do to one side, you always need to do to the other side, no matter the circumstance you're in. So what we need to do is we need to subtract 3 from the other side to keep the equation balanced. So if you're not understanding this at this level, then we could simplify it a bit. So if you have 4 equals 4, you know those two are equal, but if you add 2 to one side, so you get 6 equals 4, you know those are not equal anymore. But if you add 2 to both sides, you're going to get 6 equals 6, and those two are equal, and the same goes for subtraction. So now we know that both sides are equal because we subtracted 3 from both sides. And that's going to be equal to x equals 7 minus 3. And that equals x plus 4. And now we could plug in 4 back for x, and we can get 4 plus 3 equals 7, which is correct. So that's a more methodical way of solving algebraic equations rather than guessing what x could be. So now we have a more complicated algebraic equation. So in this case, it's the same thing as last time, but x now has a coefficient of 2. So in this case, the first thing, you always want to isolate the term with the variable first. So we still want to get rid of the 4, and remember that the inverse of subtraction is addition. So what you want to do is you want to find the opposite of 4, and that's positive, or of negative 4, and the opposite of negative 4 is positive 4. So we need to add positive 4 to both sides, remember, to both sides, and that's going to be equal to 2x equals 14, because 10 plus 4 is 14. But now we haven't isolated x itself yet. We've only isolated the term with x, because we're not trying to solve for 2x, we're trying to solve for x. So now, as I said before, when you have a coefficient for a variable, that means that the coefficient is being multiplied by the variable. So in this case, 2 is being multiplied by x. So what you need to do is you need to divide 2 now, because the inverse of multiplication is division, and the inverse of division is multiplication. Because if you have something multiplied by a number and then you divide it by that number, that's going to be equal to the number itself. So once you divide 2 to both sides, remember it needs to be to both sides, you're going to get x is equal to 7, because 14 divided by 2 is 7. So you might be wondering, 2 divided by 2 isn't 0, it's 1. And that's what you want when dealing with only multiplication and division, because anything multiplied or divided by 1 is itself. So when dealing with addition and subtraction, you want it to be 0 because anything plus or minus 0 is itself. But with addition and subtract or with sorry, multiplication and division, anything times or divided by 1 is itself. So in this case, the opposite or the inverse um, of 2 is dividing by 2. Um, so that's going to be equal to x, and then that's going to be equal to 7 because 14 divided by 2 is 7, as I said before. So now we're going to get into a bit more complicated stuff. In this case, we have variables on both sides of the equation. So here we have 3x plus 7 equals 5x minus 1. So in this case, we have terms on both sides of the equation, as I said, but we need to remember, isolate the term with the variable on one single side. So before dealing with any of these variables, you want to deal with the terms um, not having variables with them, or in this case, x with them. So that's going to be 7 and 1. So anytime you're doing anything with algebraic equations, you want to try your best, if it's possible, to keep the equations or the numbers you're using um, positive. So instead of subtracting 7 to the other side, we'd want to add 1 to both sides. And you might be adding or asking, why subtract 7? Because the opposite of plus 7 is minus 7, and the opposite of minus 1 is plus 1. So in this case, we want to add 1 to both sides because we're adding 1 to get rid of the minus 1 on the right side of the equation, but you need to do that to the other side as well. So that's going to equal 3x plus 8 equals 5x. But now we need to make sure all the terms with the variable end up on one side. So what we need to do is we need to get rid of the 3x on this side and add it to the other side. So 8 is on one side and the variable terms are on the other side. So what we need to do is we need to subtract 3x on both sides. Since this is a positive 3x, the opposite of positive 3x is negative 3x. And you might be asking, that's a term I always use, why can you add and subtract terms that deal with multiplication? Because here it's 3 times x. In this case, we're not adding or subtracting 3 itself. We're adding, or we're subtracting in this case, the whole entire term, which is being added to 8. So we're allowed to subtract the whole entire term. So here we're subtracting all of negative 3x from both sides because you need to use the property of equality and it's also subtracted to the other side. So now we're going to get 8 equals 5x minus 3x. And using like terms, that's going to be equal to 8 equals 2x. Because 5 minus 3 is 2, and then you add the x at the end. And now we need to get the inverse of 2 of multiplying by 2. Because right here we have 2 times x. And as we did in the last example, we need to divide by 2 because the inverse of multiplication is division. So that's going to be equal to 4 equals x. But whenever you're solving for an equation, you always want it to be the variables on the left side, so you could just switch the 2 around, and that's going to be x equals 4. And if you plug it back into the original equation, that's going to work. And the same goes for if you have division. So in both of the examples I gave with multiplication division, it was always multiplication and then the inverse is division. But if you have, for example, 8 equals x divided by 2, then the inverse would be multiplying by 2. So that would be 8 times 2 equals x now, and that's going to be 16 equals x. But that's only if you have like x divided by 2. Um, so now that we know some parts of algebraic equations, um, and how to solve one with variables on both sides, with dealing with multiplication and addition and subtraction, here are some practice problems. So the top part is simple problems. So they're similar to the first two examples we did. The next three are moderate problem. So it's similar to the last problem we did with variables on both sides. And then the last one is a challenge problem, but those include parentheses and distribution. So if you're not familiar with those topics, no need to do those. Of course, all of these are optional, but if you want to get better, then I encourage you to try these out. Um, and the challenge problem is only if you're familiar with these topics, or if you, of course, want to learn these topics, then the challenge problem is a good way of applying these to more, as the word says, challenging problems. So, just a disclaimer, all answers should be positive integers. So none of them should be fractions, decimals, negative numbers. And if you get one of those, then you should attempt trying it again. And if you get a positive integer, who knows if it's correct, who knows if it's wrong, and the only way to know is if you plug the number back in and and both sides end up equal, then you know that you got the right answer. So, if you didn't know, well, obviously you didn't know, but my name is Naveen Desai. I have a twin brother, and some of my hobbies are playing football, tennis, and writing poetry slash creative stories. And thank you for joining me in this curriculum, and I hope you learned something. And if you want to explore more, I encourage you to watch YouTube videos, or if you're learning this in school, I encourage you to share your knowledge with peers or your teacher. Thank you.